Okay, so now we're going to solve rational equations, right? We started by graphing rational functions. Then we did simplifying rational expressions. And now we're doing solving rational equations, right? That's always the pattern. You got to, for every function, we do those three things. And, you know, part of this that I just don't know whether we're going to get enough time to do it, but this is coming exactly from the SOL. And if you read it, the part of this that we clearly always do is the first part. It says solve the equations algebraically. But there's also actually the way that you solve it graphically is the way that you can solve any equation graphically. And we haven't really done much with that. Definitely before we get to the SOL, we should. To me, something like that is not teaching you a calculator trick. That's teaching you how to use stuff in the way that it's supposed to be used. And we really should know how to do that. So we'll see if we get time for that. If we don't do it today or with this lesson, we'll do it sometime in the future, I'm sure. Come on, why is this so slow? There we go. So solving rational equations algebraically. So a lot of these things, they should sound pretty familiar. Factoring the denominators. Okay, we did that in adding and subtracting. Finding the LCD. Okay, that's something that we've been doing for all the problems we did last night. We were finding LCDs, right? Multiply both sides by that LCD, right? Now it's different now because when you have an equation, as long as you do the same thing to both sides, you're okay. When you just have an expression, whatever you multiply in the numerator, you've got to do in the denominator so that overall you're multiplying times 1. With an equation, that's not the same, right? As long as you multiply both sides by the same thing. And if you remember, we've had in two different kinds of functions equations before this, we had this concept of extraneous. Do you remember what extraneous was? Extraneous meant you solved for it, you got it, you know, completely correctly. You solved for this answer, but when you plug it in, it doesn't check. That's extraneous. And so we have the same concept here. At least we call it the same thing. It's actually not. It's not exactly the same thing, but it's close enough to the same thing. They do use the word extraneous. There's only 11 slides today. The first two and the last two kind of don't count, so 7. Short. Okay. Bergen's okay? You okay? Let me know. Emily? You okay? Okay. So here's an example, taking it one step at a time, right? And again, you should have those steps out when you're doing this stuff. And first step said factor the denominators. So in this problem, the denominators, 2 of them could be factored. Come on. I have a feeling this whole thing's going to crap out on me. So this shouldn't be there. Okay, so two of those could be factored when I factor them. There and there. Right? That shouldn't be a mystery how I factor those. What's the LCD? So look at every denominator and see what factors there are. The first one's got a 2x plus 1. The next one's got an x plus 1, and it's got an x minus 1. And the next one's got an x minus 1. So overall, the LCD will be 2x plus 1, x minus 1. Okay, so factor the denominators. What does it say to do? And factor the denominators, find the LCD. We did that. Now what? Multiply, right? So I'm going to multiply times 2x plus 1, x minus 1, times 2x plus 1, x minus 1, times 2x plus 1, x minus 1. Right? Multiply both sides, which means every term, by the same thing. I mean, that's just basic algebra. Whatever you do to one side, you got to do to the other. And what does it say after that? Yeah, notice that now, in every term, the denominators will cancel. Because you've got the LCD in the numerator, it will cancel the factors in the denominator. Like the 2 cancels with the 2, and the x plus 1 cancels with the x plus 1. In the second term, the x plus 1 times x minus 1, they both cancel, like that. And in the last one, just the x minus 1 cancels. Give you a chance to catch up with that. What's left? In this first term, there's 1 times x minus 1. What's left in the second term? 10, right? There's a 5 times 2, 10. And in the last term, 2 times x plus 1. So whatever's left at that point, you solve it according to the methods that you have. If it's a linear equation like that, then it's pretty much basic algebra. I get the x's on one side, everything else on the other, solve, right? If it's quadratic, then remember, how do you solve quadratics? You know, just whatever's left at this point, solve it the way you solve it. Right? This one would be x plus 9 equals 2x plus 2. Subtract x. 9 equals x plus 2. X equals 7. So what is the last step? Check. Now this time, for extraneous, really what you're looking for is not so much does the left equal the right. By all means, you could check to see whether the left equals the right. What we're looking for here is that one of our answers, we only have one, that when you plug it into the denominators, it doesn't lead to a divide by 0. Because sometimes that happens. You end up with an answer like if we would have had one of our answers to be 1, then we would have had to throw it out because you can't have 1. 1 would lead to a divide by 0. But with 7, you know, 2 times 7 plus 2 does not equal 0. And 7 squared minus 1 does not equal 0. And 7 minus 1 does not equal 0. So in all three cases, we don't have an issue with that. So no extraneous. Right? Now you could have a wrong answer, but you don't have an extraneous solution. Good, Shana? Jessica? Yeah. Yes. Yeah. We'll have one that comes up like that in the examples here. So try to do the same thing with that one. Here's the steps. Here's the steps. You're going to do that. And I'm going to come around and sign it at your desk and not pick it up this time. So if you want to do it in a notebook, that's fine too. So if you're having trouble with the factoring part, that's the factoring part. If you're having trouble with LCD, there's the LCD. Yeah, sure. Yes. Did you check it? We'll go back up to the original. Just make sure that doesn't lead to any of the non-zero spins here. Okay, but you did everything else right. Nope. Nope. That's 2x minus 4, 5, 6 plus 10, 6. That should have been 7x and plus 6. Okay, did you check it? Good, and it's not extraneous. Good job. Many, many, many correct answers. What's that? Sure. Oh, sorry. Fix it, and that's right. And that's right. That's right. Not done yet? No. How did you get an x plus 1? That's why it's not working out. Okay. Okay. Now there was a over x plus 2 there. How did you end up with an x minus 2 in the denominator? You don't have an x minus 2 in the denominator. You just said that. And you're not multiplying top and bottom, right? You're just multiplying both sides, which means every term by the x plus 2 times x minus 2. Okay. 7x. Okay. So the right answer was 0. Right? If you factored correctly, that was the factoring. The LCD was that. The next step was you multiplied every term by the LCD. And then you canceled. You know, in the first term, the x plus 2 cancels. In the next term, the x minus 2 cancels. And the last term, they both cancel. And so what's left is 2 times x minus 2, which is 2x minus 4. 5 times x plus 2, which is 5x plus 10. And 6. So 7x plus 6 equals 6. 7x equals 0. X equals 0. And then if I plug it back in here, 0 plus 2 does not equal 0. 0 minus 2 does not equal 0. 0 squared minus 4 does not equal 0. So this is not extraneous. It's good. Yeah. You look at every factor in the denominators, right? What do you see? Okay, so there's an x plus 2. What do you see? Okay, what do you see? It's already there. X minus 2, it's already there. Okay, there's your LCD. Okay, we've been doing that for 2 days now, right? So you have to just look at, after you factor all the denominators, you write down every factor you see, the most times you see it in every fraction, right? And every one of these is just there once in every fraction, so that's it. Now, it used to be the book, before they rewrote it for this year, they actually made more of a distinction between 2 different kinds of problems. And there was a difference between this kind of a problem, which is not a you try, this is a me try, right? Which is actually a fraction equals a fraction. And the ones that we've done up till now have not been just a fraction on one side and a fraction on the other. This kind of problem, you have to do this way, right? You have to. This kind of problem, you could cross multiply. Since it's just a fraction equals a fraction, you could just do this, right? Cross multiply, and then you have no more denominators. In one step, you could do that. So this is what it would look like if I did it that way. I would get x plus 3 times x squared minus 16 equals x plus 2 times x squared plus 3x minus 4. I mean, at that point, it's not a rational equation anymore. There's no more denominators. Now, this particular problem is a fairly complicated problem, which I'll carry through just to show you. But in the end, at least it's not a rational equation. See, how do I simplify what's on the left? It's a FOIL, right? So let me do x squared times x is x to the third. 3x squared negative 16x. And 3 times negative 16 is negative 48. Okay, how are we going to multiply a binomial times a trinomial? No. Yeah, I mean, if you can keep it straight just by making sure you multiply everything here, x times that and 2 times that, that's fine. Last semester when we were doing this stuff in chapter 5, I showed you that you could use a grid like this. Right? I can say, put one factor on the left, x plus 2. Put one factor on the top, x squared plus 3x minus 4. And now just fill in the grid. That will make sure you take into account every multiplication. So like this will be x to the third, 3x squared minus 4x. 2 times x squared, 2 times 3x, and 2 times negative 4. So when you multiply 2 terms times 3 terms, you get 6 terms. Now some of them are like terms and you can combine, right? If you notice 2x squared plus 3x squared, 6x minus 4x. So when I combine all of that, it looks like this. X to the third plus 5x squared minus plus 2x minus 8. Now, is that a cubic equation? It sure is the way it's looking right now, but what will you do as the first step? Subtract the x to the third. They both have a 1x to the third, so when you do that, it'll be a quadratic after that, and we know how to solve a quadratic. So, like, take a step and just subtract the x to the thirds. And now it looks like 3x squared minus 16x minus 48 equals 5x squared plus 2x minus 8. And it's a quadratic. I'm going to need to get everything on one side, 0 on the other. So I will subtract the 3x squared from both sides. That'll give me 2x squared. I'll add 16x to both sides. That'll give me 18x. And then I'll add 48 to both sides. That'll give me 40. Okay, getting easier. How could I simplify that? Chad? Factor what? Well, no, it's not a greatest common factor. I mean, yes, there is one. What is it? There's a 2. You could divide out a 2, right? Because otherwise, when you see that number in front of the x squared, you might think, I got to do that complicated factoring thing. No, you don't. Divide out a 2 from every term, and you'll get 0 equals x squared plus 9x plus 20. And now that's a pretty basic factoring problem. How does it factor? What? What are the factors of 20 that add up to 9, Shane? X plus 4, x plus 5. I factored out the 2, remember? I divided out, so it's just an x squared. Okay, now what are the values of x that solve that? X equals negative 4 and negative 5. Okay, but here's an example of the extraneous. If I plug negative 4 here, I'm going to get 16 minus 16 is 0. So that's extraneous, right? If I say negative 4 squared minus 16 equals 0, that means that that one right there is extraneous. That means the only answer is negative 5. Now, they're not all that hard. I mean, that was a particularly hard one. Before I do that, try to do that one by cross multiplying. See ya. Remember, look on the website, right? There'll be video, homework, everything. Try to, I'm saying right here, don't do all that. Cross multiply. Get it? I don't even remember. 5x plus 15, 6x plus 3. Yep. You get it? Yes. Curtis? What's that say? No. What is this? I can't hardly read this. So you should have said 6x minus 3 on one side, then 5x plus 15. You subtract the 5x and you get an x. What is wrong with this? Seems like we got some wrong. 2x minus 1. Please check your guys for a second. I'm not seeing the.
I didn't write the original equation.
Let me see yours again. 5x plus 15 subtract. Oh, actually, it's not 12. Because it's 2x minus 1, not plus 1. You're right, Curtis. You're right. Yes. You get it? So when you add 3 to both, that becomes an 18. Okay? So it should have been 18. 18. Who got 18? You got 18? Good job. 18? 18? Okay, good job. 18. Hunter, did you get it? Okay. Okay? Now, like I said, the cross multiply, you can only use that if you have what's known as a proportion. A fraction equals a fraction. There can't be more than one term on one side. You know what I mean? Like that. That's more than one term, right? It's a rational, it's a fraction plus a fraction equal, yeah, can't do it. Okay, can't do it. Now, but notice the advantage. We got what we got. That was pretty complicated. We had two answers. We had to throw one out for extraneous. Yeah. Well, I mean, Josh is asking, essentially what you're asking is, what if you just added these together and then you did have a fraction equals a fraction, then you can cross multiply. And if they had the same denominator already, even better. Just add them up very easily and then cross multiply. But notice that when I solved it this way, I got the two answers and I had to throw one out. Note, I'm going to do this one the other way and see what happens. Right? This factor is like x plus 3 over x plus 4 times x minus 1 equals x plus 2, x plus 4 times x minus 4. We're just factoring the denominators. The LCD is so you got an x plus 4, an x minus 1, and an x minus 4. And then I multiply both sides by all of that. Right? And then I cancel what I can. I can cancel the plus 4 and the minus 1. I can cancel the plus 4 and the minus 4. Blue. And now what do I have left? I've got x minus 4 times x plus 3 equals x plus 2 times x minus 1. Right? FOIL both sides. X squared minus x minus 12 equals x squared plus x minus 2. Okay. Subtract the x squareds. When you subtract the x squareds, they cancel, right? So now you're left with negative x minus 12 equals x minus 2. So I add the x to this side, I get 2x. I add 2 to both sides, I get negative 10. So x equals negative 5. I didn't get both answers. By doing it this way, I didn't get an extraneous that I had to throw out. And that'll happen. If you do it the way where you multiply by the LCD, you're probably going to avoid getting the extraneous in the first place. And you may still think that for a particular problem, like that one, it's still a lot easier to do the cross multiply than to be doing LCDs and all this stuff. Now, the last part of it about the graphing. The thing about the solving by graphing, it's not really just rational equations that can be solved that way. You can solve any equation by graphing by, in this case, and this is that problem that I just did twice, right? We did it once by cross multiplying, and we did it once by multiplying by LCDs. If this side equals this side, then what you do to solve by graphing is you put them in the calculator on two different lines. Make it y equals this and y equals that on the two lines, and then look for where the graphs cross. That will be the solution. Now, if you remember, do I have that on? I think I do. I already have that in the calculator. So I put it up there, and notice I use that fraction format. Right? If you don't use the fraction format, you got to make sure you got parentheses. But do you remember how to put it in a fraction form like that? How? Right? You go second quick. I'll do it on the screen. Alpha y equals 1. That's how you get that. So you can just enter these in as a fraction right away. So that I already did that. You could try to get the same thing. Now, one thing that I usually do, and it doesn't really make that much of a difference, is if I'm going to have two graphs on the same background, I like them not to have the same line so that it's clear which one is which. Like the first one, I'm using the normal line that's usually used. But the second one, I'm using a fatter line. Right? You get that by scrolling into the left margin and then hitting enter. Right? If I see, I'm on the normal, what it normally is on, and when I hit enter, now it turns into a fatter line. So on the graph, it would be fatter. But I've already done that to this one, so I'm going to switch it back. I'm just going to keep hitting enter until I get back around to that one. There we go. Now, if you look at that graph, it's a mess. It is very hard to see what's going on in that graph. No question. Do you think you can see any vertical asymptotes in there? I mean, doesn't it look like right at -4, because we're dividing by, we have an x plus 4 factor. It looks like there might be something at x equals 1, and we have x minus 1 as a factor. And it looks like we've got another vertical asymptote at 4, and we've got x minus 4 as a factor. So this graph, like rational functions always are, it's discontinuous. It's got three parts. It's got one part which is to the left of -4. It's got one part which is in between -4 and +1. It's got another part, it's actually 4 parts, in between 1 and 4. And it's got another part which is to the right. So if you just, these are the steps. I don't think I can do all this unless I move this over. Right. So I do zoom 6 because that just gives me the graph like that. Now I do second trace, and intersect is 5. Okay, second trace, intersect. Remember, what does it say above the trace? It says calc. So it's a calculate menu. So second trace, 5. Okay, and I choose that. And notice that it says x equals 0. It's starting out with the cursor right in the middle of the graph. And it's prompting you for first curve. And you can see it's using the first one, x plus 3 over right there. So just hit enter. Okay, just hit enter. And when it says for the second curve, it just jumps to the other curve. Okay, I hit enter. And then it says, do you want to guess? And when I hit guess, notice what happens. It gives me an error. It says, basically it's telling you it's not finding any place where they crossed. Okay, so here's what you do. Go back, second trace, I think I got to quit first. Second trace 5, and this time move the cursor to another piece. We were in between -4 and 1. How about if we scroll over, look at the x value, it's -1, until we get it to the other side of -4. Okay, now it jumped to the other piece right there. So you see it? Okay, now that we're in the other, that part of the other side of the vertical asymptote, say enter. And for the second curve, say enter. And now say guess. And it jumped to it, -5. There's our answer. It's jumping to the right. You don't even have to pay that much attention to which one it's on. But how do you know? When you do second trace 5, it's telling you in the corner there which one it's on. There's the first one. There's the second one. Guess? Yeah, you always guess. And it goes to the answer. So I think with these rational functions, you need to just move the cursor into the area, to a different area. Like I've already done this one. I tried it once here, I tried it once here, and once here. And I got errors in every one except for the one over there with the -5. And that was the only answer. We saw that. That was the answer. Again, you could have done this for any equation that we've done up till now. You could have solved that way. Yeah. It won't give you the extraneous solution. It will not give you the extraneous. You do not have to worry about that. This one will only find you the real answer, and you won't have to do the extraneous. Okay. Unfortunately, again, we don't take these calculators home where you can practice with that, but it was part of the objective for this SOL, so we did it. If you want to write that down real quick, then I'm going to do about a 5-minute reminder of what's on the quiz, and then we'll take the quiz.